Okay, what we're heading toward is constructing a graph. This is our quiz problem. Everybody got it. Now, the way I want to write this out, the way I recommend you do, so you see all the logic of it. This equation breaks into equation x plus 5 equals 0, or x minus 3 equals 0, or 2x plus 6 equals 0. And that might be a little hard to read, but we can see what it is. And this has solution. Put a few dots in. You can always subtract 5 from both sides, but we have x equals 5, or x equals 3, or x equals negative 3. If we solve each of these equations, and they're very straightforward, simple equations to solve. Now, sometimes you won't have a really simple equation to solve. Sometimes you might even have something that's downright impossible. But as a, well, we'll see. Okay. So what does this tell us? So we can sketch a graph here, set of coordinate axes. And actually, there's a window that would go with this graph, but I'm not going to talk about that just yet. But we see that the x values go from -5 to +3. So let's just put x equals -5 here. And x equals 3 here. And then x equals -3 is going to go about here. So those are 3 points on the graph, and that's really easy. If your polynomial is factored, it's really easy to find all these points. At least all the x-axis, the x-intercepts. Okay, that's good. What's the y-intercept? So we'll discuss this for a minute. Okay, as always, as with linear functions or quadratic functions or any function, the y-intercept occurs when x equals 0. Okay, so can you apply that to find the y-intercept of this function? So if you let x equal 0, you're getting p of 0, which means you're going to substitute 0 for all the x's. And when you do that, you get 5 times -3 times 6, which is -9. Now I'm going to emphasize this with a star and an exclamation point. On the y-axis, x is 0. So if you plug in 0, you're going to get the y value for the point on the y-axis. And if I multiply correctly, this is what I get. Now, if you don't totally understand that, you need to ponder it, but we're not going to take the time to ponder it right now because we need to develop this. But this is something you need to maybe go back and ponder a little bit. Take it in your notes, make yourself a note to really review it and think about what it means. In any case, we get y equals -90 when x is 0. So let's just go ahead and draw a point here. For y equals -90. Make sense? Now let's see, x is -5 here. What if x was -8? That's about as far as we can go in this graph. If x is -8, we can evaluate this. We're going to get -3 times -11 times -16. Okay, we can plug in -8 for x. If I did that right, we're getting -3 times -8, which gives us -24. And we multiply that by, that's not -16, -10, which is good. -24, or yeah, -24 times -10 is -240. So between here and here, the graph is going to go, the value of the function is going to drop from 0 to -240. Well, -90 is right here. -240 is over twice that far down. So this graph is going to go down really fast here. Okay, so I'm just going to say when you get over here, the graph goes down really fast. So it's going to do something like this. Okay. Now, if you don't have that picture in your paper, go ahead and put it on your paper and see if you can draw a curve. It starts like this, turns around and goes through this point, comes down and goes through this point, and then turns around, comes up and goes through this point. In other words, you want to go through all these points, but you want to keep moving to the right. Okay, so just connect the dots, draw a smooth curve that connects this dot, and this dot. Starts here, stays smooth, connects these 3 dots. See what you get. Another thing I should have said, the only way this thing can equal 0 is if x has one of these values. Because if x doesn't have any of these values, then none of these are going to be 0. So you can only go through the x-axis at these 3 points. Now, as always, when we do this exercise, nobody here did anything that I haven't seen 1,000 times. Majority of students won't do this right on the first attempt, but we need to understand why it has to be this way. Okay, so what I see is people come up here and they go through here and they come down to here, and then they want to go through the x-axis up here and come back down or something. You can't go through the x-axis here because the x value here is not -5. It's -5 over here. It's not -5, so that can't be 0, right? And whatever the x value is here, it's not -3, so this isn't 0. And if the point is here, it's not 3 either. I'm sorry, it's not -3, so this one can't be 0, but it's not 3 either, so this one can't be 0, right? If x isn't one of these three values, none of these will be 0, and when you multiply them out, you're not going to get 0. Okay? That's the reason that you can't go through the x-axis anywhere except at these points. So what you're constrained to do is you pretty much, this is what everybody pretty much ended up with after they got over the impulse to go through the x-axis, where they can't go through the x-axis. It's going to be something like this. It's going to come down here, maybe go through here, maybe go down a little more, and then it's going to curve around and come up very steeply, and it's going to get really steep. Okay? Now, how do we know it gets really steep? Well, let's just say here's -3. Let's say we want to let x equals 7. X equals 7, you could put the numbers in yourself. You get 7 plus 5 is 12, right? 7 minus 3 is 4. 2 times 7 is 14, and add 6, you get 20. So you have 12 times 4 times 20. Okay? Well, 12 times 4 is 48, and 48 times 20 is 960. Okay? So the x equals 7 point I'll say this just a little more. That's 960. That's 10 times as far as this. On this board, we can only go up 1, 2, 3, 4, maybe 5 times, and we got to go up twice that more. So up through the ceiling. Okay. And then what if x equals 10? You think it's going to be much more than 960? Figure it out. You plug in 10. What's P of 10? So just on your paper, write. Don't have room to write it here. P of 10 equals, and then substitute 10 for all the x's in this definition and see what you get. Oh, heck. Doggone it. Why'd you let me do that without recording? Okay, I accept your apology. I'm going to go back and say what I said. You go ahead and do what I'm talking about here. I'm not sure what I'm recording and what I'm not. Apparently, I got carried away looking at what people were doing, didn't record a lot of what I just said. And I'm pretty sure I said this, but let's just go back to this picture. Your rule is you can only go through the x-axis at the points where P of x is 0. If you're not at one of these points, P of x isn't 0. Okay. If you try to go through the x-axis here, which people often try to do, and then turn around and come back down. Well, whatever that number is, it's not -5, so this isn't 0. This number's not 3. There's 3. This is a different number. This isn't 0. And it's not -3, here's -3, so this number isn't 0. So you're gonna get three numbers and none of them are 0, so you aren't gonna get 0, so you can't have that point on your graph. Now, we look at what happens. We look at what happens if you go a few units to the left, you go to -8, this thing goes right down to -240. So it goes down rather steeply on this side of the last 0 on the left. Okay, if you move past the last 0 on the right, let's say up to x equals 7, you got to go way up because the x equals 7 point is at what y value? Well, y equals p of 7. That means you put in 7 for x, and you're going to get, you do that, you're going to get 960. So that's way up. 960 is over 10 times this far. It'll be up through the ceiling. And then if you went out 3 more units to x equals 10, you'd have to go all the way up to 2,730, which is 3 times as high as this. This is already through the ceiling. That's through the roof, and then more than the height of the room beyond that. A distance that you really wouldn't want to fall. You're likely to get injured. Okay. Point is, this thing goes up really fast. So what happens as you pass the last 0 on the right is it goes up really fast, or possibly if I put a negative sign in this, we'd have a polynomial where the graph is upside down. It might go down really fast, but it's either going to go up or down really fast when you pass the last 0. And same thing over here, if you're going to the left, you pass this 0, it goes down really fast. Now I want to say what I've been wanting to say all along, but I kept not recording. Okay, now I've written out the same p of x function that we've graphed here. I've written out the formula again, and we're going to expand this formula, which means that we're going to take any two terms. We'll take the first two, any two factors. We'll take these first two factors and put them in a big parenthesis so that we can just operate on those for right now. So in that big parentheses, we've got this, but this means x has to multiply x minus 3. And 5 has to multiply x minus 3. And that then, if you multiply x times x minus 3, you get x times x. And then x times -3, which is -3x. Then we have 5 has to multiply x. And 5 has to multiply -3. Now I'm going to write this out as x squared. Now minus 3x plus 5x is plus 2x. Then we have minus 15. We're going to multiply that by 2x plus 6. Now, how are we going to do that? I'm going to give you a minute, see if you can figure out how to do that. And then I'll show you if necessary. Okay. Now, people have a little trouble with this. Think about this. This multiplies this, right? That means that this x squared multiplies all this, 2x multiplies all this, and -15 multiplies all this. So that means we have x squared times 2x plus 6 plus 2x multiplied by 2x plus 6 minus 15 multiplied by 2x plus 6. Okay. Now see if you can multiply all that out. All right, now we have to multiply some more because x squared is multiplied by this, 2x is multiplied by this, negative 15 is multiplied by this. So we have x squared, well, it's going to multiply the 2x. And it's going to multiply the 6. And now the 2x is going to multiply the 2x. And I'm kind of out of room, but I'll just kind of wrap around here. And the negative 15 multiply 2x. And negative 15 will multiply 6. So we write this out a little more compactly. X squared times 2x. Bring the 2 out in front because usually the number goes first. And x squared times x is x cubed. And this is just 6x squared. 2x times 2x, 2 times 2 is 4, and x times x is x squared. 2x times 6, 6 times 2 is 12, that gives us 12x. Negative 15 times 2 is negative 30, and we have an x. And then we have negative 90. Now we can simplify that because 6x squared plus 4x squared is 10x squared. 12x minus 30x is negative 18x. And then we have negative 90. Now we can kind of check to see if this agrees with this function. For example, this function is 0 when x equals 3, right? Well, I'm not gonna take time for you to do it, but if you plug in x equals 3 here, x cubed would be 27, 2 times that is 54. 18 times 3 is 54, so this would be negative 54. So you got 54 here, minus 54 here, that adds up to 0. And 10x squared, well, if x is 3, x squared is 9, 10 times 9 is 90, and there's a negative 90. So it works, okay? At least it works for x equals 3. And if I'd made a mistake in here, chances are that it wouldn't work. So that's a good way to check. If you've got the factored form, you know where the zeros are, check the easiest one to check. And 3 is the easiest one. It's the smallest number, and it's positive. It's not negative. So I think we can conveniently conclude that P of x equals, I'm going to start over. I need to leave myself enough room to write it out. Two x cubed plus 10x squared minus 18x plus 9. Now, suppose x equals 1,000. I'm going to show that only this number really matters. This number is so much bigger than all the rest of these numbers that we can almost ignore those numbers when x equals 1,000. We can't ignore those numbers when x is between, like, ouch, ow, -5 and 3, okay? Because those numbers really matter. But when x gets really big, it doesn't matter. And I'm going to show that. Then okay. Now I just put 3 dots here for the -18x and the 90, partly because I didn't leave myself room to write it out, and partly because those numbers really aren't going to matter much. 1,000 cubed is 1,000,000,000. So you get all those zeros and you multiply it by 2 and you get this. Now you get some zeros over here too. But this thing has 3 more zeros, not to mention it has that 2 in front. And I'm saying that this number that you get for 2x cubed is 2,000 times bigger than the number you get for 10x squared. And I lied, it's only 200 times. Still, it's a whole lot bigger. Okay? For large x, like the way that sentence is coming out, I'll just say the higher power term overwhelms the others. Okay, so I say the graph of P of x is dominated by y equals 2x cubed when x is large. This gives us a picture like this. let's say we have X equals 1,000 here. X equals negative 1,000 here. On this scale, if the graph goes through this point and this point, the graph is going to look like okay, here's a graph of y equals 2x cubed. And the graph of this function that we just did looks almost exactly like the graph of y equals 2x cubed. Except when you get close to 0, maybe it wiggles a little bit. So I'm kind of drawing a little wiggle. The wiggle won't be that big. But you get this. And here are the wiggles. If you zoom way in on this with a microscope, so you can see the interval from -5 to 3. Now that's negative 1,000, that interval will be very small, pretty much invisible. Maybe with a good magnifying glass, you would be able then to see very close to the origin. You'd see this little bit of wiggle, okay? And it doesn't go nearly as high or nearly as, and it's not nearly as wide as I indicated here. This is just kind of a schematic diagram. Very close to the origin on this scale, you would see a few wiggles. So it's the wiggles that we're really interested in. We know that this is going to act like the graph of 2x cubed when we get away from here. So you have the wiggles and then it just takes off. Well, that's what happens. You have the wiggles and then it just takes off. Okay, now remember what I keep nagging you about and everybody else, and pretty much nobody's doing it. When you do this, set it up, say, okay, we're going to find the x-intercepts and write out they occur when y equals 0. Write that out. If you're writing that out every time you do one of these problems, you're going to remember it. If people aren't remembering it, and I'm afraid you're among them, everybody here, okay? And you have a lot of good company because we've got a lot of good people that don't remember it. Doesn't mean you're a bad person. It just means that you're setting yourself up not to do well in the midterm. Okay, you need to write these out. You can't just memorize it the night before the midterm. You need to write it out every time you do a problem. It doesn't take long. You focus on other things, focus on this, because this is how you remember how to do the problem. Okay. Then after you write this out, okay, then focus on, okay, what the heck does that mean? But you write that out. I see some people skipped a step. They just went directly to x plus 4 equals 0, x squared minus 16 equals 0, x minus 3 equals 0. You would get the right solutions there, but you're skipping an important step. You rewrite. y equals 0 means that p of x is 0, since y equals p of x. And then you can solve this equation. Okay? And again, you ought to write that out. The words are going to pretty much be the same for any polynomial, any factored polynomial when you're trying to find the zeros. So there are words we could write here, but we don't want to get too wrapped up with the words. We do want to write the word or. There are ors and there are ands, and they're important. Then you can solve these equations. What about that equation? X squared minus 16 equals 0. And I'm observing something about this 0. This is like a transformed quadratic or squaring function, shifted 4 units to the left. The way we can see that is x squared minus 16 is x plus 4 times x minus 4. You can multiply that out and verify this. We'll talk more about factoring pretty soon, like real soon. Okay. So you can write the x plus 4 here. You can place x squared minus 16 by x plus 4 times x minus 4. And then you have the x minus 3. That could be written in, there's an arrow here and kind of got slopped up. But it's like you got x plus 4 squared right there. Those two terms give you x plus 4 quantity squared. And then you have the x minus 4 and the x minus 3. Our zeros are at x equals negative 4. And there are two zeros at x equals negative 4. The one from this and the one from this. If x is negative 4, this is 0, and this is 0. That 0 has multiplicity 2. That matches the fact that x plus 4 squared is in this factorization. Then x equals 3, multiplicity 1, meaning only occurs in one term. X equals 4, multiplicity 1 only occurs in this one term. The lesson for the graph is, if a 0 has multiplicity 1 like x equals 3, then the graph goes through this point. If you narrow your vision down to a very small region around this point, it pretty much goes through like a straight line, not like a parabola, the vertex of a parabola, not like a cube, okay? But like a straight line. And similarly here with another 0 multiplicity 1. Over here, multiplicity is 2, so it acts like a parabola in the immediate vicinity of this point, in the very near vicinity. And we can even see what the parabola would be, because near x equals negative 4. This function is close to x plus 4 squared times, well, just substitute negative 4 for these x's, you get 4 minus 4, negative 4 minus 4, negative 4 minus 3. This is negative 8 times negative 7, which is 56. So you get 56 times x plus 4 squared. Near this point, this whole function acts like 56 times x plus 4 quantity squared. That's only very near this point. Because obviously, if you start moving away from the point, thing gets a little lopsided, that's no longer a parabola. And it's too steep to be a parabola here, but just for a little tiny distance along here, it's actually pretty doggone close to that parabola. Not very well drawn. Chalk has its limitations, so do I, but there it is. Okay. And that's, whether you totally understand that, it should help convince you that the thing has to be like a parabola near its zero multiplicity 2.